Janet and Rabia.
Welcome to Everest Physics Academy.
Before we start, we'd like to recommend our Everest Physics books for high school,
where you can find more explanations and solve applications and problems.
In this video, we are going to define the capacitor, explain the working principle of the capacitor, explain the charging of the capacitor, and explain the discharging of the capacitor.
Capacitor. What is a capacitor? A capacitor is an electrical component used in many electronic devices like computers, radios, telephones, TV sets, etc. Capacitor, sometimes called condenser, is composed of two conducting surfaces or plates facing each other and separated by an insulating material. The insulating material between the plates or the surfaces is a dielectric, such as dry air, rubber, mica, plastic, ceramic, etc. This figure shows some forms and styles of capacitors. In a circuit diagram, this figure represents the symbol of the capacitor. This experimental simulation explains the working principle of a capacitor. A capacitor is formed of two conducting surfaces facing each other and separated by an insulating material. In this simulation, the insulating material is air. Initially, and on each plate, the number of the electrons is equal to the number of the protons, so each plate is neutral, and we say that the capacitor is uncharged or neutral. Observe what will happen when we connect the upper plate of the capacitor to the positive pole of the battery and the lower plate of the capacitor to the negative pole of the battery using this switch. We observe that the upper plate of the capacitor loses a certain number of electrons, while the lower plate of the capacitor gains the same number of electrons because the positive pole of the battery attracts some of the free electrons on the upper plate of the capacitor, so this plate becomes positively charged, and since the lower plate of the capacitor gains a certain number of electrons, so it becomes negatively charged. This phenomenon is called the charging of the capacitor. Electric equilibrium is attained when there is no transfer of electrons between the battery and the capacitor. Now, since we have charges or accumulation of charges on the two plates of the capacitor, so we have a potential difference between these two plates, or a potential difference is created between these two plates. Let's measure this potential difference using the voltmeter. We observe that the voltmeter measures a voltage of 1.5 volt, equal to that of the battery. Now observe what will happen when we disconnect the battery using this switch. We observe that the potential difference between the two plates remains 1.5 volt, and the charge on each plate doesn't change because we have an insulating material between the two plates, so electrons cannot transfer through this insulating material. Now, the charged capacitor stores electric energy and acts as a small battery. Now observe what will happen when we connect this charged capacitor to this lamp using this switch. We observe that the lamp glows for a certain time interval and then it dies out. And also we observe that the volt between, or the potential difference between the two plates, decreases to zero, and the charge finally becomes zero because the excess of electrons on the lower plate of the capacitor transfer through the lamp to the upper plate of the capacitor. So finally the charge on each plate becomes zero and the voltage becomes zero, so the lamp dies out. This phenomenon is called discharging of the capacitor.
Focus, please. This is important.
Let's summarize the charging process of the capacitor. So here we have the battery of constant voltage 1.5 volts. Here we have the capacitor. R is the resistance of the charge circuit. Now, plate M is a metal body, so it contains free electrons. These free electrons are attracted to the positive pole of the battery. So some of these free electrons are transferred to this positive pole. Look at plate M. It loses electrons, so it becomes positively charged. Now, electrons circulate in the circuit towards plate B, which becomes negatively charged. Take into account that the number of electrons lost by plate M is equal to the number of electrons gained by plate B. Also, QM and the QB, I mean the charge of plate M and the charge of plate B, have the same magnitude, but they have opposite signs. QM is positive and the QB is negative. Now, let's move to the direction of the charge current. The electrons flow in the circuit counterclockwise. By convention, the direction of the current is opposite to the direction of the flow of electrons. This means that the charge current is clockwise. Now, another important remark. The electrons circulate in the circuit, but not through the dielectric, which is the insulating material between the two plates, because the electrons cannot flow into or through an insulating material.
So we can conclude that during the charging process, the current enters the capacitor through its positive plate. The capacitor acts as an electrical load or receiver and stores electric energy. The voltage across the capacitor increases in the transient phase. The capacitor is completely or fully charged when the voltage between its terminals becomes UC maximum, which is equal E.
Focus, please. This is important.
Let's summarize the discharging process of the capacitor. Look at the discharge circuit. We have the completely charged capacitor and the lamp. Now look at plate B. It is negatively charged. It has an excess of electrons. The electrons on plate B are attracted to the positive charge of plate M. But as we have seen in a previous slide, the electrons cannot transfer directly from plate B to plate M through the dielectric because it is an insulating material. Instead, the excess electrons are transferred through the wires and the lamp towards plate M. Now, when all the excess electrons of plate B are transferred to plate M, the electric equilibrium is attained and the capacitor becomes uncharged. Let's move to the direction of the discharge current. Look at the flow of electrons. The flow of electrons is counterclockwise, so the direction of the discharge current is clockwise. Now, I want to compare the direction of the discharge current to the direction of the discharge current. In the charge circuit, the charge current flows into the positive plate of the capacitor. But look at the discharge circuit. The discharge current flows out from the positive plate of the capacitor. So, the direction of the discharge current is opposite to the direction of the charge current.
So we can conclude that during the discharging process, the current leaves the capacitor through its positive plate. The capacitor acts as a generator and restores or supplies energy to the circuit. The voltage across the capacitor decreases during the transient phase, and the capacitor is completely discharged when the voltage between its terminals becomes zero. Thank you for watching. If you like this video,
subscribe to the channel, hit the like button and share.